hi, I'm Matt Marone from Mercer University in Macon, Georgia.
And I am Dr. David Hurd from PennWest University.
And you're listening to
White Canes Connect.
Hey there, PA Federationists. Welcome to another episode of White Canes Connect, presented by the National Federation of the Blind of Pennsylvania. My name is David Goldstein. I am the treasurer of the Keystone chapter. Joining me today is co-host Emily Gindelsberger. She is president of the Parents Division. Emily, how are you today?
I'm doing great, David. Thank you for having me on today.
Well, I really appreciate you sitting in today. We're coming to your end of the state, and it'll be good to get your perspective, which we'll do after the interview. But we had a couple of very interesting guests today.
Yes, we have two very interesting, to me, of course, because I grew up always wanting to learn more about astronomy and physics. And we came through and found Dr. Matt Marone from Mercer University and Dr. David Hurd from our very own state of Pennsylvania up at PennWest University out here by me.
They really have a lot of great information on how they instruct students who are blind and visually impaired to learn astronomy. Like most things, blind folks can just reach out and touch, okay, that is a plate, and I'm going to cut the apple on that plate. You can reach out and touch those. The stars are a little further away than that. So there's obviously some different ways that you have to instruct students in that. And I'm guessing that Angelina has done some things from some of their teachings. Is that correct?
Yes. As a matter of fact, our first introduction to Dr. Hurd was about 4 years ago down at the National Convention in Florida. He brought in this wonderful tactile map of the solar eclipse that was happening that year. And so through that, I was aware of him. And then Dr. Marone was featured in an article that actually circulated on some of the NFB pages as well. And so we felt it was now the time to really start focusing on tactile interpretation for our blind students so that they can continue in the STEM fields like these two gentlemen.
Let's take a listen to the interview. Dr. Marone and Dr. Hurd, thank you so much for joining us today.
Oh, thanks for inviting me.
Yes, thank you, David.
So, gentlemen, I'm really glad that you could join us as well. This is Emily, and my first question, and both of you can answer this. What brought you to wanting to adapt astronomy for people who are blind and visually impaired?
This is Dr. Hurd from Pennsylvania Western. I teach here at the university. I also run the planetarium here at PennWest University. And many years ago, I'm thinking it must have been 20 years ago or so, I had a student who was blind in my planetarium course. And I had this argument with our dean that, no, I'm not going to have this student. Don't you understand? This is totally visual. And the dean said, no, you are going to have this student. And because he carries more clout than I do, I determined, well, I kind of want to keep my job. So I guess I better go ahead and take this student that happens to be blind. And the rest, as they say, is
History.
That's right. Thank you, Dr. Marone. So that's kind of how I got into it. And I can tell you some more details also. It's really a fabulous story about the history of this university and what we were doing for students with disabilities and how it really got me caught into astronomy. But that's how it all began, was my resistance to having a student who was blind in my class. Shame on me. But here I am today.
Well, I've got a little bit of a different story about how I got involved in this, but it was also about 20 years ago as well. And I'm just going to give you a hint of that story. So when you come to the conference, you can hear the rest of the story, as they say. But in this case, I was working as a summer faculty member at Marshall Space Flight Center. That's at the NASA Center in Huntsville, Alabama. And I consult for them. I'm still consulting for them for like the past 20 years. And one of my friends in astrobiology, so, you know, you think about astrobiology, she's a biologist, but she's someone who's considering the possibility of other life forms being out there in space, existing on maybe a planet, maybe an Earth-like planet, or maybe something completely different. And, you know, out in Huntsville, we have Space Camp. And so that year, there was a group of space campers that were coming to Space Camp. And my friend was going to talk to them about astrobiology and extremophiles. Extremophiles are life forms that live in extreme environments like super hot temperatures or maybe very acidic pH. And we have these on Earth. Things that live near deep sea vents that are very, very hot and so forth. So we call those extremophiles. Well, she was going to be talking about that. And I have a background with meteorites. And so she wanted me to talk about meteorites. And then I was told, well, actually, this is a group of space campers that have disabilities. They will all be blind. Some of them will be confined to wheelchairs and have other disabilities as well. So that was kind of interesting. And then the question was, all right, so how am I going to do this? We wanted to talk about impact craters. And so I came up with a way of like basically filling up a swimming pool, a little baby wading swimming pool with different types of grit and coarseness. And then we were tossing balls into the little baby swimming pool, and the students could feel the coarseness of the different materials that started out in layers but got all disturbed by the impact. And then we were pouring molten wax on top of these craters to make a casting of the crater. So the students could actually feel the shape of the craters formed under different conditions, like the ball coming in more parallel to the surface or bouncing off the surface and forming a central uplift in the crater. So that got me actually started to think about how to do astronomy and science with blind students. And there's a lot more to that story. Like I said, that I'll tell you some other interesting things that happen with that when we're at the convention.
Those are excellent answers and stuff that sounds like a lot of fun to do with students.
How did it go over with them? Were they excited by that? Because to me, did you have, first of all, did you have a lot of time to come up with that plan, or was it something they were coming in tomorrow and you had to come up with something?
It wasn't quite that they were coming in tomorrow. I had a few weeks to plan out what I was going to do. And so I kind of, you know, did some dry runs and experiments and throwing balls into the sand and choosing different materials of different coarseness so that they could feel it, so that there was enough tactile contrast, so that they could feel the lower layers that came up during the impact, and then practicing pouring molten wax onto the sand to make a casting of it. So I had some time to prepare for doing that.
And how about you, Dr. Hurd? When you had that blind student, how did it go that term?
Oh, it did not go terrifically well, but but that's because I was just starting. Like Dr. Marone said, it's kind of like, okay, what? Of course, I was in the throes of class, so it wasn't as though I had any forewarning of this. But it was then that I discovered that here at the university, we actually have, or had, we no longer have, but we had a tactile lab. We had a full-time person devoted to nothing else but helping out the students who are blind here at the university. And so when I went to him because of this student, I find out that, first of all, he loves astronomy. Second of all, that he's a brilliant artist and forming these masters to do thermoform images of. So it was kind of very kind of interesting how it came together, and being that he really loved astronomy, made for a great relationship, and we started to make some of these astronomy materials so that my student could succeed in my class.
And what happened to the lab? You say it's not there anymore. What happened?
It is not their funding, funding. Yeah, it just wasn't a priority. And isn't it interesting how they did not, when he retired, they did not replace his position, and our number of students who are blind, of course, decreased also, which is, I think, a shame. But I do understand budgetary issues, but yeah, it was primarily a budget issue.
If there's a student there today, how do you help them if they're in your class now? How does that work?
Yeah, that's a terrific question. We have, and again, this is Dr. Hurd speaking from Pennsylvania Western University. We do still have an office for students with disabilities that's very helpful. It's just that they don't specialize maybe in certain disabilities. So thankfully, by now, I've built up enough tactile materials that I'm okay. But that was due to the fact that I was working directly with this gentleman, John Matelock, at the tactile lab at the time to develop these materials.
Dr. Marone, I know you had mentioned meteorites. Do you have samples do you have things that the blind students can feel or touch and go over? Anything like that?
Yeah, I do have a collection of meteorites, but actually I haven't been dealing with blind students at the university. What I have been was working on was with students at the Georgia Academy of the Blind.
Okay.
And I'm just getting started with them. We had put together a sort of a small science exhibit that the students at the Georgia Academy of the Blind would be involved with. And it is still currently on display at the Macon Museum of Arts and Sciences. And so they were preparing something for the Museum of Arts and Sciences. And I got a phone call from one of my friends, the curator there at the Museum of Arts and Sciences, saying, well, we want to do this work with these students from the Georgia Academy of the Blind. And so how would you go about doing astronomy with blind people? And I thought, okay, that's challenging, but I have some ideas. And I like to do planetarium type shows with my students. And my class is very observational. We spend 3 hours a week looking through telescopes out in a remote site. So it is a very observational class at the university. But what I'm doing with the Georgia Academy of the Blind students, that was a bit different. And so I said, well, maybe we could do a small scale planetarium show. We have a very good planetarium at the Museum of Arts and Sciences. But the question was, how could we do this? And that led me to thinking, well, I could start trying to 3D print constellations. And so what I wound up doing was 3D printing some small, plastic squares that are a few inches on edge that correspond to a constellation. And so we did the constellation Orion with them. And so the constellation is printed on 3D printed on a plastic square, and then it has English text on it, and I also have Braille text on it, and then I have the constellation Orion, and the stars are represented by hemispheres that rise up from the surface. So they stand out from the surface, just like Braille dots standing out from the surface where the caption is, and they stand out, but their diameter is related to the brightness that we see them in the sky. So their apparent brightness, I have scaled that to the diameter of the spheres. So the really bright stars are big spheres that are like 5-6 millimeters in diameter, and the very dim stars are down to a millimeter or even a half a millimeter in diameter. And so they form hemispheres that stick out of the surface of this plastic square. And then there are connecting lines that go from one star to the next that follows the standard way of connecting these constellations. And so I have the connecting lines and I have the stars. And then what the students did at the planetarium show, each student had one of these 3D printed models in their hand, and then I led them through it. I have it set up so that the star Betelgeuse is over the letter R in Orion on the Braille text. And so they find the letter R in the Braille text, and then they move their finger up and they come in, hit a big bump, and that's the star Betelgeuse. And so then I start talking about the star, and then I move them around the model and say, all right, now, move your finger up and you'll feel this, or move your finger to the right and you're going to feel these 3 stars in a row, and that's Orion's belt, and find the uppermost star, put your finger on that. And then I talk about the stars that make up the constellation, and they're feeling them, so they get an idea for which ones are brighter and which ones are dimmer. And I can ask the students, as I teach them the names of those stars, I can ask them, well, is this one brighter than the previous one? And of course, the answer to that is, does it feel like a bigger hemisphere under your finger than the previous one does? And I lead them around the constellation and talk about the properties of the different stars that way. So
and
that's
do you do this within the planetarium while you're doing, do you do the show
yes.
actually in there? Okay.
Yeah, so I have the planetarium show going. Some of the students were low vision, and then there were also chaperones with them who were sighted. And so the sighted chaperones are seeing this up on the screen, and the students are holding it in their hand and feeling it and moving their finger along. And sometimes the chaperones too were helping to guide them a little bit, make sure they had everything oriented correctly as they were moving around on the surface of the 3D model. That's how I got started on that. I'm also doing some stuff with math models, but we can talk about that a little bit later.
Dr. Hurd, how about you? Any artifacts other than 3D printed stuff? How do you, other than the tactile things that we spoke about earlier, do you have anything like that?
Yeah, I'm working with a group out of San Jose State University, and we are making some 3D models. And so we have some 3D printed galaxies. I also have some meteorites that I take when we go and present to groups so they can hold the meteorites. But we also have, from what I know, the first 3D actual printed models of meteorites also. So we use those, which is kind of fun. But I'm really a low-tech guy. I'm not a 3D printer kind of a guy. I'm kind of the low-tech, make the master, use the thermoform machine, and we're very proud of it. Dr. Marone, I love what you talked about with Orion there. And we do something very similar we have a full star chart, what we call planisphere, a braille and tactile planisphere. And Dr. Marone, we also use the same thing. We gauge the size of the bump related to what we call the star's magnitude or brightness. And so obviously the brighter the star is, the bigger the bump. And so we have a star chart that we use for that. If students happen to come here to the planetarium that are blind, we have those planispheres that we can use to find different constellations. We have several different books. We just have one that we're really excited about that we'll share at the conference, and that's just got funded, and that's one on light pollution. So that's a really interesting concept. How do you get light pollution across to maybe someone who's never had vision? Okay, so we think we've come up with a creative way of illustrating the effects of what we call light pollution. So as far as artifacts, I guess I don't have a whole lot of them because we resort almost exclusively to our tactile materials.
Talking about the light and the brightness of a star, in reality, does that gauge the size of that star? The brighter usually is the bigger?
Not necessarily.
Right. You got distance in there as well.
Okay.
Yeah. There's lots of different factors that go into that. Of course, astronomers, we like to use this term called absolute magnitude. Okay,
Mhm.
magnitude is kind of a general term for how bright a star appears here from Earth, right? But as Dr. Marone alluded to, just because a star's bright doesn't mean it necessarily is really bright. And just because a star is faint doesn't mean it's necessarily faint, because we need to factor in this thing called distance.
Okay.
And so when we're talking about this term called absolute magnitude, what we astronomers like to do is we like to mathematically move all the stars to the same distance from Earth. And
Mhm.
once we mathematically move those stars to the same distance of Earth, we're eliminating the variable of distance. And then we can actually tell how intrinsically bright that star is. Okay. And so that's what's called absolute magnitude. For example, before I go on, the magnitude scale is an inverse scale, or maybe I should say it's counterintuitive. In other words,
That's right.
the brighter a star is, the lower its magnitude. Okay, did you catch that?
Okay.
So the brighter a star is, the lower its magnitude is. So, for example, Vega is a star in the northern hemisphere sky right now, almost right overhead, just after the sun sets. That happens to have a magnitude of 0.00. So if anything's brighter than Vega, it's going to have a negative magnitude. If anything's fainter than Vega, it has a positive magnitude. The brightest star in the night sky, a star called Sirius, has a magnitude of negative 1.25. But before you jump on the Sirius bandwagon, you got to know that, is it bright because it's a really bright star, or is it bright because it's relatively close to Earth? And in that case, it happens to be, well, I'm not going to tell you. You show up for our thing on the conference, and maybe we'll discuss that some more.
There's another factor that goes in there too, about the temperature of the star and how much energy is radiated per square meter of surface area of the star. And again, you have to take all these things into account: the distance and the temperature, the brightness that we see. And then even if we're talking about the eye or a camera, we don't see in a linear way. And so these scales are actually sort of logarithmic function, and yeah, it gets kind of complicated.
If I could add something else, David, this is Dr. Hurd again. You talked about artifacts, and I take that and I said, well, I really don't use artifacts. I guess I really do. I think Dr. Marone and I both probably do a lot, because we love scale models. And
Yep.
scale models are, right, they might not be the actual artifact, but they help us understand about our universe. So I have a tactile scale models of a lot of different things. In fact, we do an audible scale model of our solar system. All right. And also at the conference, I'll show you, if we were to shrink our sun down to a certain size, how big would other stars be compared to our star, the sun? So we'll be looking at some of those scale models that give us a better idea, a better feel for the actual size of objects in our galaxy and even in our solar system.
And
that's
will both of you guys
mind-blowing.
be bringing things along for folks to check out?
Yes.
I will be bringing the Orion models along with me, and I'll probably lead people through the planetarium exercise that I was just talking about.
Okay.
And then I'm also doing some stuff maybe we can talk about with mathematics, and I'll bringing some of those models as well.
Okay.
And we will be doing some hands-on exploration in our session also.
One reason why this all came to be, someone a while ago actually shared an article of what Dr. Marone was doing on one of the NFB listservs.
Oh.
And that is how we came up, I was speaking with Lynn, and then she was like, all right, well, reach out to him, see if he'd be interested in coming. But Dr. Hurd here was actually at a national convention in Florida about 6 years ago now? Maybe not that long ago, maybe four.
Maybe four, yeah, something.
Yeah, so it was the year that there was the solar eclipse in August, because one of his presentations at National was he brought a tactile map of the pathway for the solar eclipse. And we were able to get a copy. He brought copies for everyone. And that happened to be the first day of school for Angelina. And, she was able to take her little map. And of course, all the kids there were like, what's this cool thing? Anything different for kids that day and age, they don't care. They just want to see what it is. So she was able to participate with her classmates. Everybody went outside, and the school had gotten everybody like the super dark sunglasses and all the safety protocols and everything to that degree. But Angelina was able to go out there and have her map, and they were able to talk about everything that happened, and she was able to participate. So, and then this summer, after we had actually spoke with Dr. Marone, so I was looking actually through OVR to find something for Angelina to do over the summer. And right after I had talked with them, they reached back out, and Dr. Hurd had an astronomy class over the summer that was a grant. Was it a grant from the state? Or NASA?
Pennsylvania Space Grant Consortium, which is funded by NASA. And so we did an astronomy camp for blind and visually impaired.
Oh, that's great.
She had a ton of fun because, of course, it was like a weekend without mom. Well, I mean, it was during the week, but they got
to stay in the dorms, eat at the cafeteria, and hang out here. And we did astronomy activities every day. And, Emily, I wanted to mention that's such a touching, wonderful story that you share about Angelina and with her with her classmates, because for a change, she was able to contribute to the learning experience. And in fact, maybe even to a certain degree, she was leading the learning experience.
That's what I was thinking. She was leading that learning experience.
And I think that's really neat. And one of Dr. Marone's, my goal is to equip these students to actually help lead in learning.
That's really great.
She did. And that's, I think, ultimately the reason why we wanted to reach out for you guys to come to convention, so we could bring this, because right now with children especially, some TVIs don't know how to adapt things. Like TVIs are the teachers of the visually impaired, and they're given a lot of responsibility, and they cannot be masters of everything. And sometimes, tactile graphics, tactile interpretation, tactile access to these different things that other children simply take for granted are not there for us. So that is one of the reasons why we wanted to grab you guys up and bring you in. And hopefully there are some teachers that are coming, I believe, and the other adults. And I actually do have, I don't know if I'm allowed to break that secret, but
now you have to.
I have actually contacted the woman who does the planetarium work over the Carnegie Science Center. So she is going to come down, because they have started understanding the need and appreciating things to have the children come in and having alternate ways of accessing the information that they are presenting.
I'll definitely have some materials to give her to say, hey, this is a start. And let me know how I can help you out from going forward.
And that's what one of her offers was, to use us. I always offer us out there as a resource to people, because it is important, if you don't know or you're not sure, to go right to the source. And that is a big thing with the NFB, nothing about us without us. And if they can talk with us and we can give some insight or even beta test the things, that's what we love to do.
Excellent.
Well, and what you were talking about, materials for other teachers, I mean, that makes a nice segue into one of the other 3D printed kind of projects that I'm working on for visually impaired students. So if you want me to take a couple of minutes, I can talk about that as well.
Yeah, go ahead and let's hear that.
Yeah. So, and, my discussions with Emily, one of the things that she mentioned was the fun of learning algebra and the challenge of learning algebra if you're visually impaired. And so I started thinking about how we look at math functions, just simple mathematical functions, a parabola, or maybe a cubic equation, or lines with different slopes. And, my sighted students, they can see that pretty easily, right? I can make a graph in Excel or some sort of spreadsheet program, and they can see those graphs. And so then I started thinking about, well, can I 3D print those graphs? So recently I had been doing a few experiments with the Georgia Academy of the Blind and 3D printing a sort of an incised grid on a plastic sheet, and then overprinting on top of that data points for math functions. So we've been playing with parabolas, and I've been making a few different variations of the size of the points and the shapes of the points and how deep the grid lines are incised and all that, and then bringing them to the math teachers to let the students touch them and feel them and inform me about what shapes work for them and what shapes don't work for them. So I'll be bringing some of that along as an example. Ultimately, what I'd like to be doing is have this printed very quickly in the classroom. And so I've been experimenting with that, where I've been pre-printing standard grids and then overprinting the data points of the mathematical functions in about 3 to 5 minutes. So if you have a classroom 3D printer, you can put the pre-formatted grid in there and then overprint the data points onto the grid very quickly. And that way the students can actually feel the shape of the math functions, or feel the difference of the slopes of the lines, or where they intersect, and things like that, that it's easy for a sighted person to see that, but very difficult to convey that concept to someone who can't actually see the graph and has to do it in a very tactile kind of way.
I just have to ask, you had said at the beginning, the fun of algebra, and I've never heard those two words mentioned together.
Well, I think I was being a little bit sarcastic there, because what Emily was telling me was that I guess when her daughter started learning algebra, it was kind of difficult. And I know that there are systems, there are algebra blocks, and there's Nemeth code for encoding mathematical equations in Braille and so forth. But I just wanted to try to bring the ideas that we could see by just simply making a graph, but turning that graph into something tactile so that the students can actually feel the shapes of those curves and learn about the functions that way.
With algebra or any other kind of mathematics that's well beyond addition, subtraction, things a lot of people use every day.
Right.
Blind or sighted, you either have a mind for it or it's something that you take just to get through so you can get a degree or graduate or high school or whatever the case may be. So I don't know that obviously for a blind student, it's going to be that much more difficult, I think.
Yes, that's right. And I was kind of trying to look at different ways that we can help assist that, and get a feel for what these functions, these mathematical functions are doing. So the teacher can change the equation and then print out the data points onto a preformed grid. And as they're discussing the mathematics of it, the thing is printing, maybe like an old style inkjet printer kind of speed, where it took a couple of minutes to print something. And then they would actually be able to pass it around and feel it.
Dr. Hurd, now you're in Western Pennsylvania. I heard on KDKA this morning as I was listening to think, well, I'm going to be in Pittsburgh next week. Let's see what's going on out there. And I found that there is a girls soccer team from Mars whose nickname are the Planets. I thought that was very cool.
Yeah.
They've won something like 80 games in a row and have won the last 4 championships in whatever league they are. And I wasn't quite clear if it was a high school or a traveling type soccer team. I'm not quite sure. But if they win this coming week, they were going to be the champions again. And I thought it was hysterical. They're playing Moon. So
Yes.
it was Mars against Moon.
Yes,
Okay.
Moon, Pennsylvania. Yep, and Mars, Pennsylvania. They're within what, 25 miles of each
Yes.
other? So it is rather hysterical.
I went out to wait for the bus with Angelina, and in the western sky, the moon was setting, and it was about, what time did she get on the bus? 7 o'clock in the morning. And sometimes I do have some vision left, and I like to take my iPhone out there and always take pictures of the full moon or the 3/4 moon. And I did take a picture of it, and then to my luck, there was a planet, I believe, also if you were looking at the moon, it was to the right of the moon. Would that have been Jupiter or would that have been Venus? It was in the morning sky. The moon was setting in the west. I did locate the photo. The photograph was taken on the morning of October 11th.
The moon was kind of almost halfway between Jupiter and Mars on that morning of October 11th. The morning of October 11th, the moon would have been almost halfway between those two planets. So wasn't particularly close to them. Unless I'm
Well, I'll email you guys the picture.
I'm kind of wondering, Emily, at what you were taking a picture of there.
Mm-hmm. No, I wanted the moon, and so the moon it looks almost full, but like the shadow is on the right quadrant of the moon. And
because if you could back up like 2 days, October 9th, it would have been right down by Jupiter.
Yeah, exactly.
Or if you can fast forward to October 15th, it was right by Mars, but it's probably not the 15th because that's not near a full moon.
So it changes that quickly. The spots in the sky from day to day, they change that much.
That's a great question, David.
It is.
The question and the answer is, well, it depends on what you're talking about. The stars are essentially, for all practical purposes, fixed in the sky. Now they do drift to the west each night. So that's why we have seasonal constellations, like Orion is a winter constellation. Cygnus the Swan is a summertime constellation. So we see different constellations different times of the year, but as far as them changing position with respect to each other, we do not see that through our lifetimes. Okay, but the things in our solar system, right? So the sun and the planets, they do move quite quickly among the background of fixed stars. So the moon, the moon goes around it. The moon only takes a little over 27 days to be near a significant planet or star until it's by that planet or star again. That only takes 27 days. for it to go once all the way around.
And yes, early in the morning on October 9th, the moon is just a little bit above Jupiter. You're talking about 6 o'clock in the morning or 5 o'clock in the morning, something in that range.
So
All right,
yes,
I just emailed it to you guys, so
So-
you guys
so
get the.
they do move, and that's part of the fascination, David, is to just really watch these planets and things in our solar system. In fact, that's how you can truly distinguish a planet from a star. Is if it's wandering among the background of fixed stars, it's going to be a planet.
And sort of the etymology of the word planet actually comes from a Greek word that has to do with wandering, which is why Dr. Hurd said if it's wandering. I think the other interesting thing too is to talk about the ecliptic, which is sort of a line there in the sky where you're going to find the moon and the sun and the planets. They're all more or less distributed along this line that we call the ecliptic. So you're not going to find Jupiter like sitting far out in the southwest or something like that. It's going to be right along, right along the line of the ecliptic. So right along the line that the moon is traveling and the sun is traveling in the sky.
And Dr. Marone, I'd add to that too, that at the conference, we will be able to explore a star chart that shows tactily that line that Dr. Marone was just talking about, that plane of our solar system, if you will, in the night sky against the background stars.
A while back, we talked about meteorites, and
Sure.
I have a fantasy football team. I have named it. I named it in 2008, so it was the 100th anniversary of the Tunguska event.
Yes.
One of the larger of the, at least recent history, or no?
In modern history, yeah, definitely that's the largest. Of course, Dr. Marone, when was the one in Russia, Cherbinsky? Was that 5-6 years ago?
Yeah, it's probably something like that. It was quite a big fireball.
Yeah, that was a big one. And they found pieces of it too. And it shattered windows for miles around in this city in Russia. And that wasn't too long ago, but it wasn't nearly the scale of
Tunguska.
Yes,
Yeah,
thank you.
Tunguska was absolutely gigantic.
If one like that hit a major U.S. city, the city would be gone.
And I do remember that from a few years ago, that one, because everybody had dashboard cam video of
Right.
it and things like that.
And
Exactly.
Related to that, David, is of course, maybe many of our listeners recall, I want to say a month or two ago, that NASA sent, it was called DART. Okay, so double asteroid
I was going to ask you about that.
redirection test. And
Yep.
so DART actually impacted an asteroid to see how much effect the impact would have on moving its orbit, moving its trajectory. Okay, obviously with the hopes of someday being able, if we see an asteroid that's heading for Earth, we can redirect it so that it'll miss Earth. And that was the whole point of that test. That was a very successful test. I haven't really heard any recent results. Dr. Marone, have you heard any of the results from DART?
What I've seen is that they're working on analyzing it. So there were two bodies there. And what they were trying to do was strike one of those bodies and see if it changed the orbital period. So it was double, the double asteroid kind of thing in there, right? So there were two objects. And the idea was to slam this impactor into it and see if you could detect changes in the orbital period. But an interesting thing that did happen was that people have been capturing images of the debris that came off as a result of that collision. So now it looks more like a comet because it has a very discernible tail around it, which is the debris that was knocked off it. And there's about 2,000 or so currently in the catalog, potentially hazardous asteroids. And, this is something that, we're exploring and we're looking out for. Potentially hazardous asteroids are things that can sometimes even get closer to us than the moon is.
Which is frightfully close. It sounds like a long ways, but that's kind of frightfully close.
some of them are really close. Like on October 29th, there was an asteroid that missed the Earth by a distance of 0.1 lunar distances, meaning a tenth of the distance between the Earth and the Moon was
So is that
the
25,000
missed.
miles?
So that was the missed distance.
Yes, David, that was very good.
25,000 miles, right? Because it's around
Yep.
250, right?
Yep.
To the moon?
Yes.
Okay.
Now that was a small one. That was only like 6 meters in diameter. But still, these things have tremendous kinetic energy. And, you could go back if you know what the velocity is and calculate their energy equivalent. Often it's many, many times greater than the Hiroshima atomic bomb. So
Wow.
these are very, very significant. I often do these calculations with the students in my astronomy class. We look up something that is due to miss the Earth, and there are a lot of radar observations of them and velocity measurements and approximate diameters and so forth. And so you can estimate their kinetic energies. You have to sort of estimate the mass based on the size and sort of an average density of rock or something. But yeah, the kinetic energies are gigantic. And so it's really important to know how to protect the Earth from a potentially hazardous asteroid. If the people who are listening to this broadcast are interested, there's a very good webpage called spaceweather.com, and spaceweather.com keeps a running list of the potentially hazardous asteroids. So,
And I'll put that in the show notes so folks can get to that. Backing up to DART, is it possible, everybody assumed that this was not something that was going to be something dangerous for Earth. Is it possible by striking it with the rocket or the whatever it was, the refrigerator size vehicle that hit it, is it possible to have taken that from harmless to something worse?
Well, that kind of gets into an interesting question. People have debated that. And, we have these annual meteor showers that occur at the same time every year. And those annual meteor showers are the debris that's left over from comets. So as we're seeing that comet go through the sky, it's leaving a big cloud behind it, like a car going down the interstate with a smoky engine or something, right?
Okay.
It's leaving a big trail. And every year we go through that trail of debris, and that's what gives us annual meteor showers. So if you did have an object that was sort of coming at the Earth and you broke it into lots of pieces, it's a very good question to ask. What's going to happen with those pieces?
I'm thinking of the two movies that came out, I don't know, 15, 20 years ago, Armageddon and I forget the other one.
Impact.
Deep Impact. That's it. Yeah.
Although they were very stylized for Hollywood, there's a lot of truth to that hey, we have been hit in the past, and then we will be hit in the future by these large space rocks. So,
and there's discussion too, if not just breaking it into a bunch of pieces, but there have been discussions for the possible mission where you would land something on one of these things, sort of like a rocket engine, that you could land it onto the asteroid and then remotely ignite that engine and change the trajectory of the asteroid so that it goes harmlessly by. So instead of breaking it up into a bunch of small pieces, which might re-enter the atmosphere, if it was close by and it had the kind of collision trajectory with the Earth. DART was not that. But if it was something like that and you broke it up into a bunch of pieces, they may re-enter the atmosphere, and you can still have harm and impacts.
Yes, they fear, depending on the composition of the comet or asteroid, one of the worst scenarios is, depending on what angle it enters, is if they explode before they hit the Earth and shatter into a lot of different pieces. So there's, it's not just a big solid rock hitting the Earth. There's lots of different variables that could be quite dangerous.
So that's worse if it breaks up before it hits the Earth. That's the worst case.
It could be, not necessarily. It certainly could be, and a lot of times they will. A bolide is like a fairly small object that what we commonly call a shooting star, but it's not a star. It's as Dr. Marone mentioned, a piece of debris or space debris coming in, and sometimes they'll move rather slowly across the sky, even though they're moving thousands of miles per hour, and then they'll basically explode at some point in time, and they shatter into lots of different pieces. If you had a large one that exploded, 10 miles above the surface of the earth, that could be very lethal.
Yeah, the impact, the shock wave from that would be tremendous. And, Meteor Crater out there in Arizona is a good example of that.
Yeah.
It was probably not formed by one solid piece that came down and smacked into the ground. Barringer, back in the day, was actually looking for that piece because he thought he was going to mine the nickel from it and corner the nickel market. But that thing exploded in the air and sent a tremendous shock wave down. So you don't find a big chunk in the crater, you find shrapnel all over the place. I have some of those pieces in my meteorite collection. And so that thing exploded and sent that shock wave and then produced a kilometer-sized crater. So imagine that happening over a populated area, a large city like Atlanta, just north of where I am, and something is destructive of that nature.
So, Dr. Marone, are you bringing samples for us to take home then?
I wasn't planning on it.
Oh, I just thought I'd ask.
But and this also is actually related to some of the NASA research that I do as well. Many people don't realize it, but meteors also impact the moon. And so if you look at the dark or the nighttime portion of the moon, you can get bright flashes of light that come off the lunar surface. And so NASA's been studying those for years, lunar meteorite impacts. And they've been correlating them to meteor showers, but then there's also random events. And you don't have an atmosphere on the moon to slow those things down. So if you have a habitat that you've built on the moon, and then one of these objects comes in and smacks into the surface of the moon and then kicks up a lot of debris, that debris itself can be, even if the object didn't hit you directly, it's like a shotgun blast now of all this debris that came off the surface. And that can be flying off at very high speeds. And if you're living on the surface of the moon, your lunar habitat might get destroyed or start leaking, even if it wasn't a direct hit. So that's another reason NASA's been studying these lunar impacts.
Early on, Dr. Marone, you had talked about space camp. Is that still going on now? I had heard, I know my son was somewhat interested back when he was a kid. He's 28 now, no longer interested. But back in the day, he saw a movie or something and thought, I want to do that. And he actually started saving money for it. And at some point, and I'm not sure this is the same one, but it had closed down. And I kind of think the one that I'm thinking of was in Florida, but I don't know. Is that the one that you were talking about earlier? Is that still going? Is that still something kids could go to?
To my knowledge, I thought they were. There used to be a gentleman in West Virginia. His name was Dan Oates, and he actually came up about 10 years ago and presented out here in Pittsburgh. I did a parent meeting, and he presented that. But I don't think he's doing the presentations anymore. I'm not sure who's in charge of that.
It says our summer at Space Camp 2022. I think it is still running.
So it's still going. Okay.
Yeah, it's run through the U.S. Space and Rocket Center, which is basically a museum that they have there. It's just outside of Redstone Arsenal, and that's where there's a Saturn V, complete Saturn V there that you can see, and a lot of things from the early Apollo days and so forth. And Space Camp is run by the U.S. Space and Rocket Center. And I think that they are still doing Space Camp in Huntsville. I don't know about other locations. Space Camp really is a lot of fun, and the U.S. Space and Rocket Center is fun. Years ago, we used to have the NASA Apollo reunions there. And, I had a lot of opportunities to meet different astronauts and people that were working in the Apollo program.
I work a lot with Dr. Cass Runyon out of College of Charleston. And years ago, she ran a program called Southeast Regional Research or some, I don't know exactly what it was. But anyway, we we would get together. So we'd bring NASA scientists, researchers, teachers, educators, and special ed teachers together to look at materials that NASA was putting out for the general public to make them more accessible. And I'll never forget, one of our trips was down to Huntsville. And so we would don like a disability, like you might wear goggles to simulate blindness or be hearing impaired or physically immobile. And I know there's a station there that you could simulate a shuttle launch, and everybody had their own role. And so it's quite humorous because we were all pretty, we had a lot of different disabilities. So it was a fun time, but I'll never forget that. It was really fun. Dr. Marone, so about 20 years ago, when you first had you're kind of invited to, where was it? Space Camp or whatever, to work with the
it was Space Camp
students that are blind. Do you know Mike Kersjes? He was one of the first people to ever take a students with disabilities to Space Camp. And he wrote a book about it called A Smile as Big as the Moon, which is a phenomenal read. And he kind of pioneered, because before, Space Camp was kind of for the really smart and the really accomplished kids, if you will. And he said, wait, this should be for everybody. And he kind of pioneered getting students, even with cognitive disabilities, into Space Camp. And he wrote this book. It's a marvelous read, and I'd highly recommend it to any of our listeners. A Smile as Big as the Moon by Mike Kersjes. And he wrote that like in the early 2002 or something. So that'd be about the time that you were introduced or drawn in there. So that's kind of neat.
Yes, that is right about the same time. Yeah, I have never met him, but it was interesting when we were doing this work with the blind students at Space Camp. One of the students was from the Georgia Academy of the Blind. So when they introduced me from being from Mercer University in Macon, Georgia, that sparked some attention. And then the student told me that they were from the Georgia Academy of the Blind. So it was, again, an interesting connection 20 years ago that was made and got me thinking about things related to how to do astronomy and how to do science with visually impaired people. And so, and it's taken me a long time because I do a lot of different things and have a lot of different thoughts maybe. But again, necessity is the mother of invention. When my friends from the museum called and said, we want to do this with the students at the Georgia Academy of the Blind, I thought, great, I can go back and do a little bit of work in that area.
And that, to piggyback off that, Dr. Marone, I'd like to mention that's exactly right. This is a process. This is evolving all the time. Are my products perfect? Far from it. But, at least we're getting something in front of our students to help them learn astronomy a little better. And as we continue working on them and we hear more feedback from the users, our products keep getting better and better. And I think that's a real important point you brought up, Dr. Marone, that it's a process. We're trying to develop more and more stuff for these students because everybody has the right and opportunity to learn just like everybody else.
Well, and I think you have to factor in the technology, the growth of technology, because 20 years ago, we didn't have those 3D printers that were readily accessible. So I was playing with wax molds, and that was really cumbersome. But now I can sit there at my software and I can design a model that would be appropriate, and I can overlay Braille captions on it, and I can change the star magnitudes and diameters very easily in the software, and then just export that file over to a 3D printer and produce, a very useful model. I couldn't have done that 20 years ago, not easily.
As someone once said to me, it's not great being blind, but we're blind at the best time because of all the things that are available. Back in the day when you couldn't see something, you couldn't reach into your pocket and pull out your iPhone and pull up a whole bunch of different apps and say, what does this say? And read it. Like I walked around, I was in New York last week, and I was at the American Museum of Natural History, and I was there on my own. Unfortunately, it was packed that day, but I had a few hours to go through, and I was able to walk through on my own and figure out what I was looking at and what bones were there and how old they were and how they found them, where they found them, and everything like that without asking anyone. I mean, I did have to ask somebody how I could get out of the building once I was done and needed to get to the train. But again, because of the technology, it makes things a lot easier for us, whether it's learning or being mobile and doing things independently, whatever it is.
Yeah, I think that's true. I mean, I got the first impetus of this 20 years ago, and then the technology evolved to catch up with the need that we have out there, and then it makes these things possible. And now 3D printers have become so commonplace, and there'll be a lot of 3D printers available in classrooms. And so I think being able to 3D print things on the fly for the students as needed is going to be a really amazing educational experience that they can get from that.
Dr. Hurd and Dr. Marone, do you have anything else to add?
I just really appreciate the opportunity to be able to do this and actually, present these things at the conference and see how people interact with them. I'm always learning from the experience of visually impaired people handling these models and making comments and saying, oh, I can refine that and I can change that. So I need that kind of input in order to make my designs better. And so this is a great opportunity to do that, and also to let people know and to talk with people and get ideas, because the ideas are coming from the people who need it. The ideas are coming from the folks who are visually impaired, and they say things that make me think about something, and then I can say, oh, I know how to do that, or I can figure out how to do that. And so that kind of relationship is really, really important to me, and I'm looking forward to that.
This is Dr. Hurd, and I would agree with that. Yeah, ditto. Dr. Marone just said. That was great. Well said. And I agree. And I am looking forward to meeting everybody. And we're excited here too, because Emily, you had mentioned about our 2017 solar eclipse book. Well, we were just funded to do the 2024 and 2023 upcoming annular and total solar eclipse books. So we're looking forward to getting those. We won't have finished copies this year, but we will next year. So look for that down the road. And we're looking forward to seeing everybody and interacting, as Dr. Marone said.
Dr. David Hurd and Dr. Matt Marone, thank you so much for coming on today.
Oh, thanks for having us.
Thank you.
Thanks again to Dr. Hurd and Dr. Marone for coming on and giving us a sneak peek of what they're going to say at the convention. And they are going to be on at 2:00 on Friday afternoon during the convention. So make sure you're in for that session. You'll get to check out a lot of the stuff that they do with their students. And I'm looking forward to doing that.
I think it's going to be an absolutely wonderful presentation. And I think the gentlemen are also bringing some surprises for those who attend.
Now, while we have you on, Emily, it'll be good to know, since you're from that end of the state, it'll be my first time in Pittsburgh. And what would you recommend somebody who has never been to Pittsburgh before, if they want to sneak away? For example, I'm not quite a senior yet, so maybe on Thursday morning during the senior section of the event, of the convention, maybe I want to get out and see something. What would you recommend somebody like me do during that time?
It depends on what you're into. We have what is called the incline, and it's the Mon Incline. It's actually a block down from the hotel, and it is a counterbalanced transit unit, if you want to put it this way. So you get in, there's like seats on it, and it goes up Mount Washington to the top of the mountain that overlooks Pittsburgh. But like I said, it's counterbalanced. So while one set of cars is going up the incline, the other set is coming down. So they kind of like pull and push each other up and down the side of the mountain. And it is actually a landmark here. It's really old. but it's really something that everybody who comes to Pittsburgh, that's what everybody does. Then you can go up and go on Mount Washington. I'm not sure if anything's open for breakfast, but there's a lot of really good restaurants up there as well. And then you can just take the incline right back down. Where we are at is Station Square, and there is a little mall area there with some little boutiques in it. There's a Hard Rock Cafe. Pittsburgh is down there as well. If you go into Pittsburgh, there's Pittsburgh was named for William Pitt. The Fort Pitt was down there. The outline is at the point. There is the fountain's not going to be on this late in the year, but you can walk there. It is Point State Park, and it's a really nice walk. There's a couple like pedestrian bridges, so you don't even have to bother with any of the traffic or any of that. And let's see, what else can you do? There is a historic strip district. If you like to go, and they have it was in one part of it, it used to be called the warehouse district, but that was right on the river, and that's where all the produce and everything will come in. So you have the fresh markets down there. You have Holy's Fish Market, which is down there. And they absolutely have a restaurant that's really good seafood there. There's a lot of ethnic restaurants down there. There's a Polish deli down there, and they do have homemade pierogies and stuff like that. So it's definitely a city if you'd like to eat. If you go down, if you take the Uber over to the south side, that is another area of just restaurants and bars. That's big, like for the college. We have so many actually schools. You have Robert Morris University down there. You have University of Pittsburgh. You have Carnegie Mellon. You have Chatham University. So there's a lot of like the party scene. The South Side is always good for that. There's the bars and restaurants down the whole thing. I think Wednesday, we might try to sneak over to the Hofbrau House. There's a Hofbrau House Pittsburgh right down there, which is really good. And so there is a Buell Planetarium at the Carnegie Science Center, and I'm not exactly sure if that's what time that opens. It might not open until 9 in the morning. There is the Carnegie Museum of Natural History. That's a little up in Oakland. It's not too far away, but it's up there. You have Phipps Conservatory if people like flowers, and you can tour there. I would have to check to see if they're, because they do Christmas flowers and stuff. Okay. And then you have the aviary if people are into birds. There's just a whole ton of stuff, including even the Pittsburgh Zoo, if anybody wants to go over there.
So some of those things, the early things that you mentioned, were fairly close to the hotel within walking distance, like the incline. Yes. And now, was the fort that you'd mentioned and where the produce area was, is that walking distance?
Depends on if you're a good walker. The fort, yes. I mean, you would have to walk across the Liberty Bridge and then go to your left down and around. It'll take you right there. If you did catch an Uber or a taxi, it's probably only a 10-minute taxi ride.
Okay.
And it'll take you right over to the point. And the Strip District, I would definitely take the taxi ride over. Actually, if people are coming in by train, the train station is in conjunction with the bus station.
Okay.
And they're right at the beginning of the Strip District, or on the other side of town from the hotel.
Okay.
So that's about 15 minutes in a taxi, maybe. The other museums, unfortunately, you would have to take transportation. You would have to get a taxi to go to the other museums around town.
Well, I appreciate you sitting in today, and it was good to get your insight on Pittsburgh. We look forward to coming out there. If folks are interested in giving us some show ideas, you have questions or comments, you have tips on how you function when you're out and about, you have an idea that might help other blind folks, please reach out 267-338-4495. You have up to 3 minutes to leave your name and town and whatever your question, your comment, your show idea, your tip, your review, whatever you've got. 3 minutes, 267-338-4495, and we will use it in an upcoming episode. You can also reach out via email at whitecanesconnect@gmail.com. That's whitecanesconnect@gmail.com. And Emily, thanks again for sitting in today.
Oh, thank you for having me, David. Take care.
Thanks, you as well. And we'll see you next week in Pittsburgh. Take care, everybody.